Welcome, Mindsets, to this grade 12 session of Learn Extra Live. Guys, I hope you're ready, and I hope you guys have got your pens and pads out for this math session. Make sure you're making notes. It's so important, because I've got the lovely Tamlin here who's going to be telling us what we're doing today.
Thanks so much, Ty. This morning we're going to be having a look at paper 2, which is including all your analytical geometry, it's your trigonometry, bit of transformations, bit of statistics. So I hope you're all ready to get stuck into it, and let's get paper 2 sorted out.
All right, awesome.
Thank
so Tamlin, while you make your way there, I'm going to tell these guys what they have to do. Guys, make sure you get on the page, www.facebook.com/learnextra. Make sure you get chatting to me. Make sure you post your questions. If you're lost anyway, if you need help, if you need to slow down, speed up, whatever it is, make sure you get on the page. So also, guys, I have these awesome winter books to give away, so make sure you get posting, and you probably have one of these being sent your way. But for now, I'm going to hand over to Tamlin, who's going to continue with the lesson.
Thank you so much. Thank you. Right, this morning we are going to begin with having a look at analytical geometry, which is generally going to be the first section that you're going to be faced with in your paper. Right, so what we have got is we're going to have a look first of all at question 1, which is this one over here. And let's have a look at what the question says. Right, we have got in the diagram, we have got a triangle where we have got 3 vertices. We've got A, which is a coordinate point of -9 and 12. We've got B, which is the coordinates of 9 and 9. And we've got C, which is the coordinates of -3 and -9, okay? We've got a point in the inside over there, which is point N. The x coordinate is an A, so we don't know what that is. We've got 7, and sitting down there in this little point over here is our theta. And that is what our question 1 is asking us to do. It's asking us to find the size of theta. Find the size of theta, which is the angle between the y-axis and your line BC. Right. What are we going to do? The first thing you need to remember is that if you are having to find the size of an angle, all right, you are talking about your angle of inclination, okay? And angle of inclination, we've got our tan theta equals the gradient of your line. That is the formula that we need to remember for our inclination, okay? Right, the next thing about inclination is that your angle of inclination is always going to be the angle that is created between the x-axis and the line that we are talking about, okay? So we're talking about line BC. So the first thing we are going to have to do is work out the gradient of line BC. Okay, so let's get going with that. The gradient of line BC is going to be found by taking y1 minus y2 over x6. That is going to give us 3 over 2. It's a positive gradient. Remember grade 12s? If our line is going in this direction over here, that is a positive gradient. And that is the gradient 3 over 2. So now what we need to do is, into our formula, we need to substitute the gradient of 3 over 2. So okay, so we're going to say tan theta is now equal to 3 over y1, which is 9, minus y2, which is -9. So please don't forget to put that in a bracket and put -9 there, over x1. x1 was the value of +9, minus x2, which is the value of -3, and once again, please don't forget to put that in a bracket. Another thing not to please forget is that your y's are always on the top. It is always your change in y over your change in x, okay? Right, what we've got then is I have got 9 plus 9, which is going to give us 18, and I've got 9 plus 3, which is going to give us 12. And if we simplify that, both of them are divided by 6. That is going to give us 3 over 2. It's a positive gradient. Remember grade 12s? If our line is going in this direction over here, that is a positive gradient. And that is the gradient 3 over 2. So now what we need to do is, into our formula, we need to substitute the gradient of 3 over 2. So okay, so we're going to say tan theta is now equal to 3 over 2. What we need to do with our calculators, we're going to take out our calculator, and we are going to press out, and we're going to press Shift we're going to say tan, and then we've got 3 over 2, close your brackets, equals. Right, so the angle for theta that we have now found is 56. Let's round it off to 1 decimal place. Let's make it 56.3. Okay, so we have now got theta, which is equal to 56.3 degrees. Okay, so let's go back to our diagram and let's just decide exactly where does that 56.3 belong. We said that our angle of inclination is found by going from our x-axis and going up to where the gradient starts. So therefore, this angle over here, 56.3 degrees, is that angle of is that angle over there. Okay, right. We are looking for this angle over here. We know that we've got a 90 degrees sitting at the origin where my x and my y-axis met each other, and we've got 56.3 over there. To find my little angle sitting down there that we need to find the size of, I can do this. I can treat it like a triangle. Now, what we know about a triangle is that the 3 angles of a triangle add up to 180 degrees. Okay, so if that's 90, if that's theta, this angle which we've now found is 56.3. If I do a vertically opposite angles, I can say that this angle inside here is also going to be 56.3 degrees because they are vertically opposite. That gives me a triangle with a 90-degree angle over here, a 56.3 degree angle over there, and my missing angle of theta, which we need to find. So our final calculation to find our theta is going to be this. We are going to say 180 degrees minus the 90 degrees that is at the origin, plus the 56.3 degrees that we found in our previous working out. And that is going to equal the missing angle of theta that we are needing to find. So 180 minus, let's quickly just work out, we've got 90 plus our 56.3, and that is giving us 146.3. Okay, so we've got 146.3 in our brackets. And obviously what we now need to do is take 180 and we need to minus our 146.3. 180 minus our 146.3. And that is leaving us with an angle of 33.7 degrees. Okay, so the angle of theta that we are looking for, the question that asked us, 33 points, and I've now forgotten, 33.7. 33.7 degrees. Okay, so that was finding the angle of theta. So quickly, let's just make sure we all understood that. We had an angle that was sitting not on the x-axis. Okay, that's something that's important to watch out for. If you've got an angle that is not actually on the x-axis, but rather sitting somewhere in the Cartesian plane, okay, and you are having to find the size of that angle, you are going to use your angle of inclination, that's for sure, okay? But when we use our tan theta equals gradient, the angle that that is going to find is the angle from your x-axis to your gradient. Once you have found that angle, you are then going to have to work your way towards the angle that we are actually trying to find, okay? So that could be by means of vertically opposite angles. We could be looking at things like adjacent angles on a straight line. There are various ways that we would be able to get ourselves towards that missing angle of theta that we are obviously having to find. But key thing to remember is that when you're working with your angle of inclination, that formula will find that angle, and obviously that will be your starting point. Okay. Right, so that's now having found our angle. So we've got 33.7. Okay, so let's move on to our next picture. Let's quickly fill in a few things. What we worked out in the previous question was that the gradient from B to C was 3 over 2. Just going to fill that in because that might just be useful in this next part. And we've worked out that this angle over here was 33.7 degrees. Okay, so we've got that there just in case we need to work with it. Okay. Right, the next question is now saying we are going to determine the value of A if it is given that our distance from B to N is 5 root 5 units, And point A is the coordinates of A, which we don't know, and 7. Okay. Grade 12s, which formula are we working with? Distance formula. Okay, right. So first things first, your distance formula is going to be on your formula sheet, and that's a nice safety net to have, but I would really suggest becoming very familiar with it, that you're able to use it without having to page back and look through your formula sheet. Okay. Okay, so let's have a look. Our distance from B to N is going to be equal to the square root of x1 minus x2. So let's start that one again. Right, x1 minus x2 squared plus y1 minus y2 squared. Okay. Alternatively, if you don't want the big square root on the right hand side, the other way we can write it is it can be written as bn squared is equal to, now putting a squared on that side basically eliminates the square root on the other side. So therefore what we would be sitting with is just x1 minus x2 squared plus y1 minus y2 squared. Okay, right, what do we know? Okay, let's go back here. We were told that our distance from B to N is 5 root 5. Okay, if we already know the distance from B to N, does everybody agree? That's where it needs to go. It needs to go into the distance from B to N. Okay, so let's fill that in. My distance from B to N, we've been told, is 5 root 5. And be aware that we're going to work with this version of the formula, which means that we are going to square that. Okay, we always like it when we have a surd and a squared because they're always going to cancel each other out. Okay, then we've got x1. Okay, once again, we're going to have to talk about the x1 and x2. So let's call this value over here x1. Let's call this one over here x2. We've got y1. And we've got y2. Okay, just take a moment to do this carefully. It's very easy to get them a little bit muddled, so let's not do any silly things like that. So x1 minus x2 is going to be 9 minus a. 9 minus a, and it is being squared, plus y1 minus y2. y1 is 9 and y2 is 7, so therefore 9 minus 7, and again that is being squared. Okay, right, what have we got here? 5 root 5 squared. Okay, 5 squared is 25, and then remember that this 5 and the root 5 are being multiplied together, so I've got 5 squared, which is 25, multiplied by the square root of 5 squared, which is going to be just 5. Anything where you've got the square root and it's being squared, what happens is that the square and the square root cancel each other out. Okay. Right, grade 12 is a very common mistake here. Just please watch out for it. If you have got a binomial, 2 terms inside a bracket, and it is being squared, a major no-no is to just go take your squared and go squared, squared. Please watch out, guys. You have to remember to do FOIL with something like that. Right, FOIL, we're going to square the first term. So 9 times 9 is 81. If I do my outers and my inners, I'm going to land up with negative 18a and plus a squared. And at the back here, we've got 9 minus 7, which is 2, and 2 squared is going to be 4. Okay, so we're looking good. Let's just times everything out a little bit more. 25 times by 5, that's going to be 125. We have got an a squared over here. We've got negative 18a. And we've got 81 plus 4, which is going to give us 85. Okay. What we're now going to do is let's bring a over. So I've got 125 over. And we've got a squared minus 18a plus 85. And we're going to have now minus 125. Right, let's quickly just get that. So if we've got 85 minus 125, that's going to give us negative 40. Okay. Okay, so what we've got is a squared minus 18a minus 40. And do you guys agree that what we're sitting with is now a quadratic equation? We're going to solve for a. Okay. We're going to factorize. What we now need to do is we need to find factors of 40 that are going to get us to 18. If we know our times tables fairly well, we can just figure this out quite quickly. If I look at 40, we could break 40 up into 20 times 2, okay? If I take a negative 20 and a plus 2, does everyone agree we're going to get to negative 18? So I've got my A and my A. I've got negative 20. I've got positive 2. And finally, when I solve for A, we're going to get an A value of 20, and we're going to get an A value of negative 2. Let's take a quick look at our diagram here. Is it possible that my A value at that point could be positive 20? No. Is it possible that it can be negative 2? Absolutely. So therefore, we are going to say that our value for A is negative 2, giving us the coordinates of point N as negative 2, and the y value was positive 7. Right, and that's that question done. We're going to take a short break, and we're going to carry on with the rest of that question afterwards.
All right,
Okay.
no problem. So mindsetters, I always tell you, make sure you get on the page, get chatting, because it is for you. And guys, make sure you call in on 0861 058 262. Why? Because the first 5 callers get this awesome pack of these winter school books. So make sure you call in. But guys, for now, we're going to see you after this break.